everyone. Good evening, good morning. My name is Raman. So, welcome to this webinar, which is organized by Cognixia. And this webinar is about Docker storage. So, those who are new to Docker, so Docker is basically a containerization technology. These days, most of the applications which are developed, it is in the form of microservices. And Docker is the best choice for running or deploying these applications as a container. We will discuss more about that in a bit. So before that, let's talk about Cognixia. It's world's leading talent transformation company, and we have 150,000 plus professionals trained worldwide, 7,000 plus industry veterans as instructors, talent development in 55 plus countries, $800 million fully owned subsidiary of Collabra Group. We are the authorized training partner for Red Hat, ITL, ISC, AWS, Automation Anywhere, Microsoft. Okay, so you can see the other information on your screen. So we provide the excellent training for machine learning, AI, microservices, RPA, IoT, big data, DevOps, cloud computing, cyber security, professional development, BI technology, etc. Today's agenda is to talk about Docker storage. So before talking about the Docker storage, let me talk about the what is containerization technology. Containerization technology is basically used to, it is best suitable for the microservice type of application. Let's first understand what is microservice mean. You can consider that a big application or an application which is a monolithic application where everything is inside one application. For example, let me just open MS Paint. Okay, so for example, we have a banking application, and in the banking application, we have, so consider this is one application, and this application is banking application. In this banking application, we are having different services. So service like we are having internet banking, we have other service, say an example, deposit service. Another part of the banking application is, say an example, it is withdraw service. Okay, so withdraw service, and one more, let's consider it as a customer care service. Okay, so this is the example of the monolithic application. So this is the example of banking monolithic. Monolithic means everything is inside one application. Everything is embedded inside one application. So this approach was good up to certain extent, but now this is not suitable as per the current development which is happening for developing the applications. So here basically what is the main problem? So if you see here that we have the banking application, and in this banking application we are having all these facilities. Now for example, if there is something wrong happen into the customer care application, then you need to shut down the entire application, whereas there is no problem in the internet banking, there is no problem in deposit service and or the withdraw service, but someone has complained that there is a problem in the customer care service, and you found that yes, there is a bug in that, and you need to fix that bug. You fix that bug, and when you are going to deploy it, you need to shut down entire application, which is basically not a good way, because other applications should be up and running. So this is more suitable for the physical servers. Okay, so it is more suitable for the physical server. Physical server means there is a server where basically hard, it has a hardware, and you are like your laptop. We'll say it's a physical server, right? Now the new way to approach is the microservice. Now what I'm going to do, I'm going to create one application. Say an example, this is the application, and this application is the banking application. Okay. Now instead of embedding all the facilities within the banking application, what I'm going to do, I'm having different services. So this is service one, which is my internet service. So I'll call it internet service, which is a separate from my banking application. I have another service which is deposit service. So this is a separate plugin. And same way, I have a withdraw service. So this is my withdraw service. And for withdraw, and I have one more service, which is the customer care service. Now these are the loosely coupled applications. Okay, these are the loosely coupled applications, and these are basically plug-in into this banking application. And all these parts like internet or deposit or withdraw or customer care, they itself are the applications, and these are in the form of binaries, or these are in the form of libraries. So you can plug these application into any application which is compatible to it. Now, what is the benefit of this? If you compare with this monolithic application, so this is the microservice approach. So this is banking application with microservice approach. Okay, in microservice, now these all applications are separate applications, and these are plugged it into the banking application. The benefit of this, as we discussed about the customer care application, if there is a problem, then that customer care application, if you want to fix that problem, then all the components should be shut down. But here in this case, if you are having a problem in the customer care application, then you need to just unplug it, fix the customer care application issue, and plug it again. So this way, the customer care application is not disturbing other components of the banking application. Same case, basically, it is for the deposit, internet, or withdraw service. So these are the separate services, right? And they are running independently, and they are plugged it into the banking application. All right. So now we are going to talk about this approach, which is the microservice approach. When we are talking about the microservice, it means these applications are not like this application. This is a bulky application. One application contains everything. Whereas I have five applications here: one internet, one deposit, one withdraw, one customer care, and the one banking application. So these are the loosely coupled application. Now to run these application, these microservices, the best approach uh, which is suitable for that is containerization technology. Okay, containerization. Containerization is basically you are using the containerization to deploy microservices. Okay, so containerization example or the tools which are available, Docker is one of the containerization tool. Containerd is also one of the containerization tool. Rocket is also one of the containerization tools. So these are some tools, but because popularity of Docker, because of its feature is very high, very demanding, and Docker and Kubernetes combination is very much acceptable by the industry. So we are talking about the Docker. So when you are running some application on a container, so container uses an image which is called the Docker image. Okay, which is called the Docker image. And Docker image is very lightweight. The reason of the lightweight Docker image is because it is without kernel. So what is kernel? Kernel is everything for the operating system, right? So if we say Linux is a kernel, so it's not wrong, because when you go into any operating system like Windows, Linux, Mac, so there is a kernel inside it which performs all the activities related to your software communication, process communication, or sending the signal from one process to another when you type something. So you can say it's the brain of the computer. And the Docker images are without kernel. And Docker images uses the kernel of host operating system. Okay, it uses the kernel of host operating system. So I'm not talking much about the Docker images because here we are going to talk about the storage. When you run the Docker image, then it is called Docker container. So Docker container, when you are running, it basically refer to a Docker image. So let us see how to. So I'm on my terminal here. What I'm going to do first, I will see whether Docker is installed or not. You can run this command docker hyphen hyphen version. So here it is saying Docker not found. It means Docker is not installed. I'm using Ubuntu operating system. So let me first install Docker. Apt install docker.io-y. Okay, so it is getting installed Docker. Okay, so Docker is installed. Let me check. that Docker is installed properly or not. How you can check it? You can run a command docker hyphen hyphen version. So you can see Docker 20.10.7. So this version of the Docker is installed, right? If I go to my browser, let me just go to my browser. And if I go to a website which is hub.docker.com, okay. So this is the official website for the Docker where all the official images of Docker are available. And the images which are publicly available for that anyone can download it. So for example, if I say I want to search for Ubuntu image, so here you can see it's an official image, 10 million plus download happened so far. And if I go and click on this, we can run this command docker pull Ubuntu command to download this Ubuntu image, and it will download the latest image. But if you want to download some specific version, so these are the tags which are supported: 18.04, 20.04, and so on. So let me just download this image. So the command which was mentioned, docker pull Ubuntu. So these images are read-only images. If you want to modify, you need to create a new Docker image. How do you check that this image get downloaded? Docker images is the command, or you can use docker image ls. So either of this command. So it returns that repository is Ubuntu and I have downloaded the latest image. This is the unique ID for each image, and this image was created 3 weeks ago, and total size of this image is 72.8 MB. Similar way, if I want to download any other image like CentOS 7 I want to download, so I'll say docker pull CentOS and version 7 I want to install. So this tag should be supported, then you can download it. So okay, so I have these two images, docker images. So you can see these two images get downloaded. Now with the help of these images, I'm going to create the container. So let me create a container. So container is an application, or say container is the one where you are going to deploy your application. So what I'll do, I will just create a container first. Let us see how to create the container. So you can run a command docker container run -it. You can give the name of the container as anything, say web container, right? And for example, I want to use a port forwarding so that I can access the application which is running which is running inside the container. So I'm saying port 80 of my host machine should be mapped to port 80 of my container. And I want that in mapping. Okay, so mapping with my volume. Okay, so let me first show you how to create a simple container, then we will see the problem why storage is required. Okay, so now let me just run this, and I'm going to use the image which is Ubuntu. Okay, so container get created. You can check this docker container ls command. So you can see there is one container get created. This is the container ID and this is the port forwarding, right? Now, if I say, if I want to go inside the container, then docker execute -id. The name of the container is web and bash. Okay, I'm using the command bash. So now I am inside the container. Here, if I run some command, if I say apt update, okay, so this is executed. Now if I say apt, let me install Apache here, Apache 2 -y. -y I'm using because uh, I don't means in between if it asks a question yes or no, it will take yes by default. Here it is asking some question for the geographic area. I'll say 6 number, which is Asia, and 44 number for Kolkata time zone. Okay, so Apache is installed. Let me start the Apache service. Apache 2 start. Service is started. We can check the status. Service Apache 2 status. So Apache 2 service is running. Excuse me. Now let us see the IP address of this machine, public IP address. I'm using AWS EC2 instance, which is 37 in my case. Let me copy this and let me go over here and try to access this. So you can see I'm able to access the application which is running on the port number 80 inside the container. This is the default application. Let me exit from the container and let me create a very simple test.html file for the demo purpose. In reality, you will have your own code. So here what I'm doing, I'm just saying h1, very simple page, uh, testing going on. Okay, so I have created this test.html. So this is ls. If I see this file is there, but this file is on my host machine. What I need to do, I need to copy this file on my container. Okay, I want to copy this file on my container. So how to copy that? There is a docker copy command, right? I'm copying this file. Which file? Test.html. Where I want to copy? I want to copy on my web container. On which directory? Actually, when you install Apache, there is a special directory which is where html, this directory. Okay, so let us press enter. Now this file is copied. We can verify from here. I can say /test.html. See, I'm able to access that file also. Now test.html, maybe you are storing some other stuff on your container like log files or database files. So that is very dangerous if you are planning to store the data inside the container. If you plan to store the data inside the container, the risky part is, or the risk factor is, that if the container is deleted, then your data will also get deleted. Okay, if you don't plan for that, if your container is deleted, then your data will be deleted. And data is everything, right? So without data, you are uh, means your company or everywhere. If you see, uh, data has a very valuable thing for the company. So if you lose your log files, database files, right? It's very dangerous. That is why we are using a concept which is storage. Okay. So by default, all the files created inside a container are stored on the writable layer, container layer. That means that data does not persist when the container no longer exists, and it can be difficult to get the data out of the container if another process need it. Okay, so if you have some data inside the container and you want to share with other containers, then that process is also very tedious process. Instead of that, we need to find some way which is very easy to access the data, share the data, right? And if the container is deleted, the data should not be lost. The data should be persisted data. So this writable layer which we are talking about. So as I mentioned earlier, Docker images, these are the read-only set of instructions. And when we create a container from this Docker image, then there is one more layer attached on top of this image layer, that's a writable layer, means you can make the changes. Okay, so Docker image remains read-only. On top of that, there is one more layer, which is the writable layer, and that is the container layer. Okay, so if we talk about the storage types, okay, so there are mainly three types of storage. One is temporary file system mount, second is volume, and third is bind mount. This is on your host machine. Temporary file system mount is nothing but you can say it's a default functionality of container. It means if your container is deleted, that data will be lost. So it's not a persistent storage. So this will be deleted if your container is deleted. So mean to say your data will be lost. Second is the volume. So let us talk about the volume. When you run the Docker, it basically behind the scene there is one service running, which is the Docker service, or we call it as a Docker daemon or Docker engine. So if I say, if you want to check that service, you can check it out whether it is running or not. It is running, that's why I'm able to run these commands. If that service is stopped, you cannot run those commands. So if I say systemctl and get not systemctl status Docker service. Okay, so you can see it is up and running. If you stop this service, let us see what will happen. If I say Docker stop, sorry, systemctl stop Docker. Okay. Now if I say Docker, say Docker images. Okay. So this command is running. If I say Docker ls, Docker container ls. Okay. So it has stopped my container. Now if I say Docker container -it, the name of the container I will say db, and I'm using the image which is say an example CentOS 7. Okay, so these things are basically working here, right? So if I say now what I'll do, systemctl, actually there is one command, docker info command. Okay, so here you can get all the information about your Docker. Okay, if I see systemctl status Docker, okay, so Docker service is running. That's why actually I was able to run those commands. So if I say systemctl and stop Docker, okay, so if I say Docker, if I check again Docker, okay, now it is in the stop state. If I say Docker version command, okay, looks like it is automatically getting started. Systemctl status Docker. Okay, so actually there is a something which is restarting this. That's why my Docker service is getting started. But in reality, if you see in production grade, if you see if the Docker is stopped, you will not able to access your containers because the service is down. Docker daemon is down. So Docker daemon is running behind the scene, and Docker daemon is taking your request, and that goes via Docker REST API. So when you run any command, so like I'm running these commands, so this is the Docker CLI command line interface. So I'm typing command over here. When I say press enter, so my command goes to the REST API and REST API to Docker engine, and Docker engine send the response again in the similar way. Now here the thing is, there is a whenever you install the Docker, there is a special directory get created, which is where lib and Docker. Here, all the objects related to Docker are available. Like there is a volume, like there is a image. So all the images information you will find actually it gets stored over here. Volume information gets stored over here. Volume is a part of that Docker storage. So if I go inside this directory, so there is few files, nothing else. Now if I create a volume, that will be managed by the Docker daemon. So see how to create a Docker volume. So if you want to see, you can see Docker volume and hyphen hyphen help. Okay, so if you run this command, so these are the commands which are related to the Docker volume, right? Create, inspect, ls, prune, rm. So I want to create a Docker volume, then I will use this Docker volume create command. So let us use this. So if I say Docker volume and if I say create, okay, Docker volume create and the volume name. Say an example, I want to create a demo volume. So the volume get created. When you create a volume, it basically creates a directory inside that volumes directory. Okay, so let us see that again. If I go to this directory, so now you can see this demo volume directory get created over here. And if I go to this demo volume directory, so you will see that there is one more directory get created, which is underscore data directory. And if I go underscore data directory, this is empty at this moment. What is the purpose of this particular directory? It will preserve your data, which you are storing inside the container. So now let us mount this volume to the container. So how to mount? You can run a command docker container run -it and the name of the container I'll just give say C1 and hyphen hyphen mount command. So hyphen hyphen mount command is used for the Docker volume. And if I say the source is demo volume, the volume which we have created, comma, destination is, destination means in the container, which directory it will be mapped. So I'm saying destination equals to, so you can give any directory name whether it exists or not exists. If it does not exist, then Docker create container will create that particular directory. So for example, if I say app directory, so I'm saying whatever the data you are storing inside the app directory, that should be stored under the this particular demo volume. And if I say minus D indicates detach mode, means your container is running in the background. And the image name. Say an example, I want to use the Ubuntu image. Okay, so my container got created, and if I say Docker, if you want to go inside the container, Docker execute minus IT, name of the container, which is C1 and bash. So now I am inside the container. If I say ls, so there is a app directory. You can see over here, there is a app directory. And now I want to go inside this app directory. For example, you are running some application inside the container and you want to store some data, whether it is your log files, whether it's your database files, you want to keep it into this directory. I'm manually creating these files, but you means if we talk about the production use case, your application log files or your database files or database log files, so or the other type of files which you want to store it, you can store it into this mapped folder. Now I'm creating files, say 1 and 2. So these two files I have created. If I exit from container and let me see this path, so you can see on my host machine the data is preserved, and where it is preserved, under my volume. So I don't need to worry now if my container is deleted. If my container is deleted, my data is still saved on my host machine. This is the benefit of the storage. So this is one type of storage where we are keeping the data under the Docker volume, which is managed by the Docker daemon. Now let me do one thing. Let me delete this container. So if I say Docker ps minus a, it will show all the containers. Let me delete all the containers. So how you can do that? Docker rm remove the containers forcefully. Which one? C1, DB, and web container. Okay, all the containers get deleted. Docker ps minus a. So you can see there is no container running. It means my container is now deleted, but my data is still saved. Let us see. So here you go. So you can see that file number 1 and file number 2, it is still there even though my container is deleted. What can I do with these files? You can attach this volume to the other container. How to attach? Let me create another container, Docker container, and if I say run, let me create another container, and the name of the container you can give anything, right? And this is a optional part. Now I want to mount my demo volume. So means source is demo volume, And destination is any destination. Say an example. Now this time I'm creating demo directory. Okay, I want my volume should be mapped to demo directory of the container. And the image, you can use any image. It is not necessarily that earlier you have used Ubuntu image. Now again you need to use, it's kind of a pen drive, right? So if you plug it into the Linux system or Windows operating system, it does not matter. Pen drive has a separate storage inside it. So I'm saying -t, and the image name I want to use CentOS 7. Okay, container get created. You can check that whether that container is having that volume attached to this or not. You can go to the Docker and inspect, or container inspect. You want to inspect web1 container. And if I come to these properties, here you can see mount. Okay, so the mount is used to display the storage related information. Here, the volume type means we are using the Docker volume. If it is bind mount, it shows bind here. Name of the volume which is attached, it is demo volume. This is the source. See, this is the same directory which I was showing you earlier. And this is the destination. Destination means this directory is inside the container. Okay, we are using local driver and other things. So here you can inspect that whether this particular volume is linked to your container or not. Now let us go inside the container. Now we have attached this volume to demo. So if I say Docker execute -it, name of the container is web1 and bash. If I say ls, so there is a demo directory. Now I am using the CentOS operating system, right? Earlier when I store the data, it was on the Ubuntu operating system. Now if I say ls demo, so you can see those two files are here. Okay, so this way, basically, we are preserving the data even though my containers get deleted. And containers are mortal in nature. They are get deleted. Okay, it does not mean these are not reliable. These are reliable, but these are keep deleting, and new containers are getting created or replace those containers. Because in the DevOps world, if you come, right, so the deployment is can be hourly based, maybe day wise. So these containers can be deleted anytime, but my data should be preserved, and that is what I'm trying to explain you here. Now let us do one more thing. Let me exit from here and let me go to that directory. Say cd/var lib docker, right, and volumes, and we have the demo volume and the data directory. So I'm here in this directory, and these two files are here. So this is the actual location where the files are available. Now let me create two more files directly here. Instead of creating inside the container, let me create it here. So I'm creating a file, creating two files. One is 3 and second is 4. Now let me go inside the container and see how many files are there inside the container in the demo directory. So I will repeat that command. And if I say ls demo, so you can see all the 4 files here. Okay, because ultimately the data gets stored under the demo volume data directory. That is why these files are getting reflected under the demo directory also. All right. So you can attach the same volume to the multiple containers at a time. So for example, I'm going to create one more container. If I say Docker container run, and if I say -it, and the name of the container, I'll call it as web2, and I'm going to mount the source, which is demo volume, and destination, anything, we'll say demo1, and I can use any operating system image. I'm using Ubuntu. Okay, sorry, I run this command inside the container, which is not correct. So if I say exit, let me go back to my home Ubuntu directory. Okay, and if I run this command, so container get created. Let me go inside the container. So I'll say Docker and execute -it web2 bash. Now if I go to this demo1 directory, and if I say ls, all the files which was under the demo volume directory, everything is here. Okay, all the files. The reason, because this container is also pointing to the same volume. So if it is pointing to the same volume, it means it is pointing to the underscore data directory. Now there are two containers, those who are pointing to the same volume. If any one of this is going to write the data, so for example, if I create a 5, or if I create two files, 5 and 6, and if I exit from here, and if I go to the other container, and if I say ls, so you can see this container also has the 1, 2, 3, 4, 5, 6 files, because it is commonly shared by the web1 and web2 containers. If you delete the volume, then this data will be lost. Okay, so most of the time this activity is done by the administrator. So before deleting the data, so he or she has to check from the different teams that I'm going to delete this data. But if he deletes the volume, then the data inside that underscore data directory will be deleted. So let us see. If I exit from this container, and if I say Docker volume ls, so there is only one volume. If I try to delete this volume, if I say Docker volume delete, and the not delete rm, to delete the volume demo volume, it will not allow me to delete it. The reason, because it is already attached with the two containers, and it is showing that these two containers ID by which it is connected. Right. Now, so it means first I need to remove the containers. So let me remove the container docker rm -1, web1 and web2. Okay, so these two containers get deleted. So now I can remove the volume. So now the volume get deleted. So if I say docker volume ls, so you can see there is no volume. If I say docker, not docker, let me go to that directory and see whether that demo volume or that data of 6 files which we have created, is it there? It should not be there because I deleted the volume itself, the parent directory. So everything get deleted. So if I say ls/var/lib docker and volumes, so you can see that demo volume directory get created. Sorry, that get deleted, and your data is also deleted. If so, if the data is deleted, so that is not a normal scenario where you are blindly deleting the directory. So you give the appropriate permissions so that only your administrator has the access to delete those directories if these are critical. Okay. So this way we are basically using the volume. So support team will basically share you the video, that recording. Okay, so there are a couple of questions. Let me cover one more topic. After that, I will take some questions. Okay, so now let us talk about another type of volume. So this is the container Docker volume which I have discussed. So what is Docker volume? Docker volume are stored in a part of the host file system which is managed by the Docker. So this is the directory on the Linux system. Non-Docker processes should not modify this part of the file system. Volumes are the best way to process the data in the Docker. And these are the commands which I have executed, right? So all these commands are available here. Now let us talk about the bind mount. See, as we have seen that Docker, if you want to manage the manage the data, then you are basically storing it into some Docker volume, one way. Second way is that you can use the bind mount. What is the difference between these two? Bind mount means you are creating your own directory. Okay, you are going to create your own directory and you map that directory to the containers directory. So destination is always the containers directory and source will be your directory. It's not a directory which is managed by the Docker daemon. It is managed by you. For example, there is some shared directory, NFS directory. So that directory you want to map with your Docker container. Then you will use the bind mount. Okay. So let us see how to create the bind mount. For example, I'm going to create a directory called my directory. And at this moment, if I go to my directory, there is nothing, right? No file. Now I'm going to create a container which will map to this my directory. So that concept is the bind mount. So if I say Docker and container run -id, I will give the name of the container, say B1, and I'm going to use the bind mount. So minus V option is used for the bind mount. And here I need to mention my source directory. So this my directory is basically under home. Under home I have Ubuntu and then my directory. So I'll give that path home and Ubuntu, and under that we have the my directory. This is my source, and my destination. You need to put colon and then the destination directory. So the destination directory should exist on the container. So here I'm saying any directory name you can say test directory. Okay, and which Docker image you want to use? I want to use any image. Say an example, Ubuntu. So my container get created. If I inspect my container, let us inspect the container. Docker container inspect, and the container name is B1, right? Now let us check the mount property. Now you can see it is bind. Earlier when we used the Docker volume, it was volume. Now it is bind. It means this container is mounted some the storage type which is bind, and this is the directory name which I have which I have found, and this is the destination. So now let me go inside this container. Name of the container is B1 bash. So I'm inside the container now, right? And if I say ls, there should be a test directory. So let me go inside this test directory and let me create some files here, say 1 and 2 files. Now these files must exist under the my directory. Let me exit from here. I'm in the my directory, and you can see these two files are here. File number 1 and file number 2. If I create some file here directly, say 3 and 4, and if I go inside the container, and if I say ls test directory, so you can see these 4 files are here only. So mean to say the actual location, the actual source is your host machine's directory, the one which you have created on your host machine. Like in my case, it is my directory, right? So, so this way, what we are doing, we are preserving our data even though container is deleted. So let us delete the container. So if I say docker rm minus f b1 f, so I'm inside the container. So if I say docker rm minus f b1, so it means I'm deleting the container b1. So b1 container is deleted. So if I say docker ps minus a, it will show all the containers. So there is no container running, right? Now it means container is deleted. If the container is deleted, but data is still saved, where it is saved? So I'll say ls under my directory. So the data is saved here because my containers. So we go on the deep level of the container cluster, then you will realize that the containers are getting deleted, new containers get created, replication is happening. So the data storage is very important in that case. So how you are sharing the data with all these containers? So the base is these storage devices, these storage types, volume or the bind mount. So now I'm going to create one more container which will map to this my directory. So if I say Docker container and run -it, name of the container I'll give as say C1, okay, and the Docker run -it name, and the I want to use the bind mount, so -v. Which bind mount I want to use? This home. Now this my directory is totally managed by you. Okay, so Docker daemon does not have much control on it. So this is totally managed by you or your system administrator. So this can be any directory which is accessible, which you can map. Okay, it can be the shared directory. So now what I'm saying, home, under home we are having Ubuntu. Under Ubuntu I have my directory that I want to map to say some other directory, say uh, M directory. Okay, you can give any name. So I'll give app1 directory. Okay, on the container and -t, and I'm going to use image say CentOS. So in this case, actually, I was using CentOS 7 earlier. Now I have mentioned CentOS. So it is basically looking for the CentOS latest. Okay, so now if I go inside this container, which is C1, Docker, execute -it, and the name of the container is C1 bash. And if I say ls, so there must be app1 directory. Yeah. So if I go to app1 and if I say ls, all the 4 files are here. If I create some file, say 5 and 6 here, now 5, 6 file is here. If I exit and if I say ls here, all 6 files are here. So for example, if you delete this my directory, let us see what will happen. So if I say cd dot dot, and if I say rm minus ifr, I want to remove recursively this my directory. Now see, my directory is deleted. The data is deleted. So this is again this kind of decision taken by your system administrator, right? And now this directory is deleted. What I want to do now, next, I will go inside the container. Okay, container exists, right? I deleted the volume, but container still is there, right? And there are no such commands which you can use for the, like in the Docker volume, we are having commands like Docker volume ls, rm. So such kind of thing is not there for the bind mount. Now Here, if I say ls and there was one app1 directory, let us go inside the app1. If I say ls, no data because there is a disconnection happen between app1 and my directory, and that cannot be established again, even though you create the my directory again. For example, if I say exit or okay, let us do one thing. If I go to app1 directory, if I try to create a file here, see, it will not allow me to create that file because the the reference directory is no more. Okay, it does not exist. So if I exit from here, right, and let me do one thing, let me create a directory. So if I say mkdir and I'm creating a directory, my directory, okay, and if I go to this my directory and let me create that file, say touch 1 and 2. So now I'm expecting that this file should exist in the app1 directory, but it will not happen. Let us try that. So let us go inside that container and let me go to the app1 directory. And if I say ls, see, still it is not showing because the disconnection which was happened earlier, it is not established again because of that operating system level, there are different IDs, different location is provided now. So if you want to refer this particular my directory again, if I try to create a file right here, again it is giving the same issue. So if you want to create particular, if you want to map that my directory to other containers, then you need to create a new container. Okay, so for this container, I cannot bind that particular container. Okay, so if I say exit, okay, files are there, but it was not referring into that destination folder of the container. So if I say docker container run minus it, and if I give a name, say C3, and if I use minus y, and under home, and there is Ubuntu. Under Ubuntu, we are having my directory. This I want, oh sorry, this I want to map to some directory, say app1, and I'm using the image which is sent to us. Created now, if I say docker execute minus it, and the name of the container is C3, and then bash. If I say ls app1, yes, now those files will be visible here. The reason? Because now I have created a new container. Okay, so this is all about the bind mount, and this is the command, right? All right, guys. So I think now we need to end the session. Thank you very much for joining.